Hi class, so today we're going to be going over lesson 3, which is primary trigonometric ratios and their application. So this is just a continuation of lesson 2. Lesson 2 is more how to do knowledge-based problems. We're focusing more on how to actually do application-based problems, so word problems with this stuff. By the end of this lesson, the things that you should know how to do is how to find and draw diagrams using the angle of elevation and the angle of depression, which we talked about in last lesson, and how to use primary trigonometric ratios to solve complex word problems. So many word problems involve trig ratios that talk about either angles of elevation or depression. So we talked about this in our last lesson. How I like to remember angle of elevation versus angle of depression is that an angle of elevation is always an angle that measures upwards between the horizon or the line of sight of the observer to an object. So if you were this person that was standing here, your line of sight is always going to be this straight line. So that's the horizon, right? And then if it opens upwards, it's an angle of elevation because it's elevating, right? So again, if you were a person that was standing here, right, your line of sight would be straight, and the angle measures downwards between the horizon and line of sight from an observer or an object. So if you were to look down from here, right, it's opening downwards, so it is an angle of depression. So an example of this would be, say you're standing outside a building that looks at an upstairs window. The angle that is your line of sight makes a horizontal, right? And then if you were going to look up, that would be an angle of elevation, because if you looked straight at the building, it would be your line of sight. And then when you look up, it's elevating, so your angle is opening up forward, right? So if you're looking straight at the building right here, and then you were going to look up at your friend, this angle over here is an angle of elevation, right? And then say your friend is up here, his straight or her line of sight would be looking straight forward towards, I don't know, the sky or the clouds or whatever it might be. And then if they were going to look down at you, right, the angle would open downward, so that would be the angle of depression. Okay? So just a few things to note. Angle diagrams or accurate diagrams are really important in this section, so you will be required to draw diagrams on your test or assignment. I'm also going to post kind of like a word bank or a vocabulary sheet for trigonometry, stuff like angles of depression, angles of elevation, transverse. All these words are important when it comes to solving word problems, so I'll post that as well for you to have for your reference so you can see what they mean. During an assignment, you are more than welcome to use that in order to help you solve the questions. Okay? So please note that accurate diagrams are super important, and you will be required to draw some of them on your test and assignments. I might give them to you sometimes. Other times you might be required to draw them. We'll go over how to do both today. Okay? So we'll start off with our first example. You have a diagram here already. It says, from a point on the ground 30 minutes away from the foot of the Peace Tower in Ottawa, the angle of elevation to the top of the tower is 72 degrees. Find the height of the tower to the nearest meter. So first things first, I like to go in and just draw my building. So it's already drawn. I'm just going to show you though how I would draw this. I always go in and just simply draw my building, right? And I say, okay, so it's going to be the square building, and it's going to make a right angle triangle with the ground because it's perpendicular. It's standing straight up on top of the ground, right? Then I know that whoever the person is standing 30 meters away. So I just like to draw a line from the bottom of the building to that person that's standing 30 meters away, right? And then I know that this person's going to go look up to the top of the building. So it'll look something like that. And then that the angle of elevation is 72 degrees. So that's why I know it's 72 degrees there. I know that from this angle, this is the opposite side. I know that this is the adjacent side. And I know that this is the hypotenuse. So if I look at all the stuff that I have an angle, I have the adjacent, and I'm looking for the opposite. So if I go back and look at ka, toa, I have the opposite and the adjacent, so I'm going to use tan. So I'm going to say, okay, tan theta is equal to opposite, right, O over A, opposite over adjacent. My theta or my angle is going to be 72 degrees. My opposite side is h. My adjacent side is 30. Right, to get rid of that 30 on that side, I'm going to multiply it. And I'm going to multiply it on this side because whatever I do to one side, I have to do to the other. And so then I'm left with tan 72 multiplied by 30. I like to just put this all into my calculator at one time. So I just put it in as tan 72 and then times 30. And that should give me 92.333. And it says to find it to the nearest meter. So I'm just going to leave it as 92 because 92.3, I just round down to 92, is equal to height. And what you should always do is write a therefore statement. The height is 92 meters. So I don't know if any of your teachers have taught you this before, but this is something similar to what I call the grass method. So if you've ever heard of this before, it's called the grass method. The first thing you do when you're given a word problem is you find out what's given to you. So we knew that we had the angle, we knew we had the opposite side, and we knew we had the adjacent side. So once I wrote that down, it was easy for me to solve everything else. Then my second question was, okay, what am I actually looking for? And I knew I was looking for height. So then A stands for analyze, right? I went in and I said, okay, I'm looking for height. What's the equation that I can use here? I went back and looked at SOHCAHTOA and I said, okay, I can use tan to find what this is. So then I had this. I wrote out the equation for myself. I solved the equation by plugging everything in, and then I made a statement, right? So this is my given, right? This is what I was looking for, my required, and then analyze, solve, and state. And if you follow this same process every time you do word problems, it'll be super easy and you'll always know what you're looking for. Because if you don't kind of have a method to your madness, then it starts to get confusing and some people can lose track of what they're actually looking for. So always try to have a method when you're trying to solve problems because it'll just make it a little bit easier for you to solve them. Okay? All right, so moving on. Let's try to use the grass method here as well. So first things first, I'm already given a diagram, so I don't need to draw anything. I just need to start using it. So it says, you are standing on top of a lighthouse. So what's the first thing I'm going to do? I'm going to start putting myself up here. Right, so I'm standing on top of this lighthouse. Excuse my drawings. But I'm standing on top of this lighthouse, and the top of the lighthouse is 33 meters above sea level, which means that from here to here, right, of this triangle, this is 33 meters, which we have written down as well. You spot a fishing boat that is 74 meters from the base of the cliff. So from here, which is where your lighthouse is, to here is 72 meters, right? So all in all, this triangle is going to be 33 by 74, right? And then the angle of depression, it's asking for the angle of depression from the boat. So this is your line of sight when you're looking outwards. This is you looking down at the boat. This angle right here is what you're trying to find. So this is the angle of depression. You do not have enough information with all of this stuff. You just have, and then, sorry, you do have enough information. So if you go in and you see, all right, that's the angle of depression. So if I just, look down and I see from here to here is 74 meters because the bottom of the boat is the same. Then from here to here is also 33 meters because it's still equally as high because that's your line of sight. Another way you could look at this is if you see, this is what we call, a Z pattern. So I don't remember if you remember this from grade 9, but this is a Z pattern, which means that the angle inside here is the same as the angle inside there. And for us to find the angle over here is pretty easy because we have a lot of information. Here we have the opposite side, right? And here we have the adjacent. So I have the opposite, I have the adjacent. I know that I can use tan to find my angle. So I'm given opposite I'm just going to write this down. Opposite is equal to 33 meters, right? I'm given the adjacent side. It's equal to 74 meters, right? I'm required to find theta, and I know I can find that by doing tan theta is equal to opposite over adjacent, and I'm just going to solve, right? So now let's solve this. So I'm going to say, okay, tan theta, which I don't know what theta is equal to, what's the opposite? 33. What's the adjacent? 74, right? So I'm just going to solve it. I'm going to come down a line. Oops, sorry. I'm going to come down a line. So I'm going to say, okay, in order to get theta by itself, I need to do inverse tan is going to be inverse tan of 33 over 74. You can convert 33 over 74 into a decimal. So 33 divided by 74 is about 0.44594. I like to leave as many decimals as I possibly can. And honestly, it's probably best if you just do this all in one step if your calculator allows you. Usually if you have a scientific calculator, it will. 5. And then just do inverse tan of that number. So theta is equal to 24. And we'll just leave it as 24. And that's your answer. Okay? So if you could, now that we've done 2 examples by ourselves, maybe pause the video here and try to do example 3 by yourself, and try to do example 4, because example 4 is a little tricky because you actually need to draw in the diagram by yourself. So that's a little bit harder of a question. So check it out, try to do that one by yourself, and then we'll take them up together. So just pause the video here, okay? So we're just going to finish up the last couple of questions here. Example 3, we already have a diagram, and then in example 4, we're actually going to draw a diagram from scratch, and we'll go over how to do that as well. So just going to get started here with example 2. Example 2 says that the shadow of a tree is 12 meters when the angle of elevation from the sun or of the sun is 68 degrees. Calculate the height of the tree. So first things first, I always like to go in and just draw in my object. So we have our tree here. It's standing at that height. So we want to find out what the height of the tree is. Right? We know that the base of the shadow is 12 meters from the tree. So it'll be 12. And then the angle of elevation will be this, right? Because you're trying to find out how far it is from the sun, or how when the sun is shining, what the angle of elevation will look like, and the horizontal is just going to be our ground. So it says let h represent the height of the tree. Here we can look at this and we can say, okay, do we have the hypotenuse? No, we don't. So we have the adjacent side and we have the opposite side, which is what we're looking for, and we have the theta. So if I was to use my grass method, I'm given the theta is equal to 68. I know the opposite is equal to h, which is what I'm looking for. And I know the adjacent is equal to 12 meters. I'm required to find the height. So if I look at this, I know I can use tan, right? So tan theta is equal to opposite over adjacent from my SOHCAHTOA laws, opposite over adjacent. So let's just solve this. Tan theta is 68 just from here. Height is the opposite. The adjacent value is 12. So we want to get h by itself. So I'm going to multiply both sides by 12 to get rid of that 12. So I'm left with tan 68 times 12 is going to give me height, right? So let's just write that in. Tan 68 times 12 is going to be 29.7, and we'll leave it at that, is equal to the height, right? And as always, so this is just my solving spot, and as always I'm going to write a statement, therefore, or instead of therefore writing it out because I'm lazy, therefore the height of the tree. I cannot write today. Tree is 29.7 meters. Centimeters wouldn't even make sense, but we know that the ground is in meters, so we assume that the height of the tree is also meters. Okay? Alright. I'm just going to go in and highlight given. You got your required, you got your analysis, you got your solve, and then you've got your statement right here. Just a really easy way of breaking down stuff. So we also know that some application questions might actually involve two right angle triangles. So we're going to use the information below to solve our unknown variable. So it says here that Rocco and Biff are koalas sitting on the top of two trees which are located 10 meters apart. There's a lot of information here already. But let's continue reading and I'll show you how to break it down. The first thing you should do is always draw a diagram. So that's the first thing we're going to go about doing right now. So it says Rocco's tree is exactly half as tall as Biff's tree. And from Rocco's point of view, the angle separating Biff and the base of his tree is 70 degrees, right? So let's just draw in our trees first, okay? So I'm going to go in and draw my first tree. I'm going to get rid of that arrow. That's going to be my first tree. If you want, you can draw a little thing on top of that. And then I can draw my little koala in here. I can't draw. I'm not an artist. But that is, and I'm sure you hear that all the time, but that's my little koala over there, right? So this is going to be Biff's tree because it's pretty tall, right? And I know that Rocco's tree is exactly half of Biff's tree. So I'm going to draw in Rocco's tree, right? Same thing. I'm going to give it a little tree top. And I'm going to draw in my little koala, right? So this is Rocco's tree. So we have Rocco and Biff's tree, and it says that the two trees are located 10 meters apart from each other. So we know that this distance right here is 10 meters. And I would advise you use a ruler when you're drawing these out. It just makes your angles and your lines neater. It's a little hard to do that for me on my iPad, but you get the idea. And then it says, from Rocco's point of view, the angle separating Biff and the base of his tree, so, right, so this is Biff, this is the base of, this is Biff right here, this is the Biff's base, right, so from here to here is the distance from him to the base of his tree. The angle separating Biff and the base of his tree is 70 degrees. So if he looks up at him too, I'm just going to go in and draw it in, right? This entire angle is 70 degrees. Okay? We know that we'll label this as Y, right? We know that exactly halfway through, right? This is going to be a right angle triangle. This is also going to be a right angle triangle. And for our purposes, Y, and this is X. Because this is going to be the exact same, and then this is going to be the added amount. This is also going to be Y, right? Because we know that those two are going to be the same, but for our purposes here, we'll label it as X. Okay? So, we want to find out how high off the ground each koala is. So we want to find Y, and then we want to find X, right? So the first thing you did was you went and drew all this stuff out. That's good. You now have a diagram to work with. It'll help you understand what's going on. After you're finished doing the diagram, the one thing you want to realize is that the angle of elevation at which Rocco is looking up at Biff is going to be 35 degrees. And I'm just going to draw that in a different color. And the reason that is because we are assuming that it's cut directly in half. The angle of elevation and depression are going to be the same, because X and Y are the same amount, right? So it says how off the ground is each koala. So let's just go look at this each individually as a triangle. So we have X here, right? I don't know what the hypotenuse is. Still don't know what the hypotenuse is here either. So I can't really use those two to solve anything. So I'm probably going to have to use tan. I have this angle here. This angle right here is 35. So I'm going to look, okay, I have it 35. Do I have enough information in this purple little dot square triangle to solve any questions for me, right? Let's look at the opposite side. I do have the opposite. Do I have the adjacent? Do I know what the distance between these two trees is? Yeah, I do. It's 10 meters, right? That information I had at the bottom. So if I was to pull this triangle out, what it would actually look like is this, right? And this is where the diagram kind of helps, but you also need to do a little bit of visualization, right? So this is 10 meters down here, right? This is X. I just pulled that pink triangle out. This is X. This angle is 35 degrees, right? I have the opposite now. I have the adjacent. And I can use my tan ratio, right? So given, I know that theta is equal to 35. I know that my opposite is equal to X. I know that my adjacent value is equal to 10. My required, I'm looking for what X is. What is X equal to, right? And I know that I can use tan because SOHCAHTOA. So I'm going to say tan theta is equal to opposite over adjacent, right? And then so let's write this stuff in. What do I know? I know tan is 35. I know the opposite is X, and I know the adjacent is 10. So in order to get rid of the 10, now I'm just solving, right? So 10 multiplied by 10 on this side, right? Just to get rid of it on both sides. So I know X is equal to 10 times tan 35. So let's put that in. 10 times tan 35 is equal to 7, right? So I know that X is equal to 7. So I know that X is how much taller this tree is than Biff's tree, or sorry, Rocco's tree, right? But I also know from before that X and Y are the same height because they are both, that the second tree is double the amount, right? So I know X and Y is the same. So then I also know that my Y, because X is equal to Y, Y is also equal to 7. So I know that Rocco's tree, which is the easiest one to solve because Rocco's tree is just the Y value. Rocco's tree is 7 meters off the ground. And Biff's tree is 2 times Rocco's tree. So Biff's tree is 7 plus 7 off the ground, right? Biff's tree which is just 7 plus 7, which is equal to 14. So Biff's tree is 14 meters off the ground. And this one's way more complicated because now you have 2 right triangles that you need to consider. So if this was a little bit confusing and this stumped you a little bit, that's okay. Try doing some of the practice problems from the notebook. They'll really help. Also, if you're like, not really sure where she got it from, maybe try erasing this or doing this on a separate piece of paper again. Try it by yourself, and then maybe you'll be able to understand and rewatch this. All right, see you tomorrow.